Did you notice that we're right where the pre-AP pre-cal is now? And we did 3 additional units that they did, and we're back right where. All right. So our learning target today is I can find limits algebraically. The first thing you do on these guys is, number 1, is always try direct substitution. Okay? If direct, and you say, well, Mr. How do you know if direct substitution works? As long as you don't get a 0 in a denominator, then you're good, okay? If you get a 0 in the denominator, you got to go back to the drawing board, okay? So the first thing you always do is direct substitution. The second is factor. Try factoring and canceling things out. Third, rationalize the radical. Rationalize. Now, we've always done rationalize the denominator, but sometimes you are forced to rationalize the numerator, okay? But that's only in these type of problems. So just know, be open to rationalize the numerator or the denominator on these, okay? And the fourth thing that's not up there, sometimes you got to find a common denominator. I'll throw that in there. Sometimes you have to find the common denominator. But like on number 1 here, I got the limit as x approaches 5. If I take 5 and I plug it in for x, did I get a 0 in the denominator? So what's your answer? 5. Number 2, the limit as x approaches 0. So the first thing I'm going to do is try that denominator. If I plug 0 in here, am I going to get 0 in the denominator? No. So can I do direct substitution? Yes. So I'm going to plug 0 in. 0 minus 5 squared over 0 squared minus 25. That gives me negative 5 squared over 25, negative 25. Negative 5 squared is 25, divided by negative 25, which is what? Negative 1 is my answer. If I was to graph it and look at that function as x approaches 0, it's going to be approaching negative 1. Bless you. Okay, number 3. If I take 1 and I plug it in there, am I going to get 0 in the denominator? No. What's 5 times 1? 5 minus 1 is?
4.
Square root of 4 is?
2.
There's your answer.
Does that have to be plus or minus 2?
No, it doesn't.
So there's no denominator, you plug in 1?
There's no denominator. You just plug in whatever number it's approaching. You see that, Jack? Okay, number 4 here. X is approaching 5. If I take 5 and I plug in, what's 5 squared? 25 minus 25 gives me what? 0. That's a problem, isn't it? Okay? And it doesn't matter if you get 0 over 0. If you get a 0 in the denominator, you got to do something else, okay? Now, let's look at our toolkit. You got factoring, rationalize, find a common denominator. Which situation do you think this is going to be? Factor. Okay, let's factor that out. Let's see what we got here. X minus 5 squared is x minus 5 times x minus 5. Difference of squares on bottom. I can cancel these out. Now, I'm going to plug 5 back into it now. What's 5 plus 5? So I got rid of that 0 in the denominator. So now you can do direct substitution. Okay? So what's 5 minus 5 in the numerator? Okay, is it okay to have 0 in the numerator? Yes. 5 minus 5 is 0 over 10, which is equal to what? 0. That's your answer.
So if it's 0 over 0, why can't we just...
0 cannot be in the denominator. 0 cannot be in the denominator. All right. On number 7, let's go to 7 first. Is there anywhere I can plug that number in? So what's your automatic answer? 12. So number 7 is quick, easy, it's 12. All right, going back to number 5 now. All right, so on number 5 here, I want you to plug negative 2 in that denominator, see what you get. Let's give everybody a chance to do that. That means pick up your calculator and try it. So what did you get? 0. So do we have a problem here? Yes. Which one of our strategies, factoring, rationalizing, or find a denominator, would you try to use on this one? Factoring. It's term for term. So I'm going to factor by what? Grouping. Okay. So I'm going to come over here and factor this. Take an x squared out. I'm going to take a 3 out. So I get x plus 2 and x squared plus 3. That's going to go on top. Now let's look at the bottom. Take an x cubed out. Take a 4 out. Can I cancel those x plus 2's out? Now, a while ago when we plugged negative 2 in, guys, and you told me it didn't work, was that right there lets you know, is it continuous or discontinuous? Discontinuous. There's a type of discontinuity. You just work that out. Right now, I can ask you, you can tell me what type of discontinuity. We know it's not jump because it's not piecewise. Is this infinite or removable? Removable. Why do we know it's removable? Because we're able to factor and cancel out. That's removable. So that means what is occurring at x equals negative 2? A whole or an asymptote? Whole. Does that make sense? Alright, so now if I plug negative 2 back in now, negative 2 cubed will be negative 8. Negative 8 plus 4 is negative 4. Is it okay to have a negative 4 in the denominator? Yes, so let's finish the answer out. So, we got negative 2 squared plus 3 over negative 2 cubed plus 4. That gives me 7 over negative 4, which is equal to negative 7/4. That would be your answer. Bless you. Number 6. If I take negative 1 and I plug it in here, negative 1 squared is what? 1 minus 4 is? Is it okay to have negative 3? So, can I do direct substitution here? Yes, you can do direct substitution here. So, negative 1 squared minus 2 times negative 1 minus 8. Negative 1 squared is 1 plus 2 minus 8 over 1 minus 4. 3 minus 8 is negative 5 over a negative 3, which would equal 5/3. I do that kind of fast. Check my math there. This is not too bad, is it? I love limits. So next in calculus, this is the first chapter. So we go quickly through. Are there any questions so far on the first 7? All right, let's look at number 8. Looking at that, what type of discontinuity will exist on number 8? A jump. Now you got 3 problems. X approaches 1, X approaches 2, X approaches 4. Which of these pieces do you think you would plug in for X approaches 1? The first one, because isn't this X less than 2? So I plug 1 in. Now remember, is that an understood negative 1 in front of that X squared? So you would square your 1 first. What's 1 squared?
1.
That becomes a negative 1, don't it? Yep. Negative 1 plus 8 is what? 7 will be your answer for that first one. Where would you plug B part in? Top or bottom? Middle. Middle, because this is or equal to. What's 2 times 2? 4. Where would you plug that in? 2 times 4 is? Thank you. Number 9. The limit as x approaches 9 of square root of x minus 3 over x minus 9. I take 9 and I plug it in. I get what in the denominator? 0. Can I factor? No. So this is not removable, is it? Is this jump or infinite? That means there's an isotope of some sort up here at x equals 9. Alright, so this situation does not call for factoring or finding a common denominator. We're going to have to rationalize. Well, the radical is in the numerator, isn't it? So we're going to have to rationalize the numerator. So I'm going to multiply by what? When you rationalize, you'll multiply by square root of x what? Plus 3. Square root of x plus 3. Just like if we were to rationalize the denominator, we change that middle sign. Now watch this. The math gets long here, but it's really easy. Square root of x times square root of x is what? X. Square root of x times 3 is 3 square root of x. Negative 3 times square root of x is? Negative 3 times 3 is? Negative 9. Yes, those cancel out on top. X times square root of x is x square root of x. X times 3 is 3x. Negative 9 times that is negative 9 square root of x. Negative 9 times 3 is negative 27. Alright, now I'm going to take my 9 and I'm going to plug in the denominator. What's square root of 9? 3 times 9 is? 27. 3 times 9 is? So that's what? 54, isn't it? Okay, let's remember 54 is over here. What's square root of 9? 3 times negative 9 is? Negative 27. Negative, so it still gives me 0, doesn't it? So now I think, oh, what can I do next? Well, I know I can't rationalize anything anymore. Yes, we're going to get there. We're not going to find a common, so I'm going to try to factor. I'm going to try to factor somehow so I can cancel out this x minus 9. So how many terms do I have down here? 4. I have 4 terms. So let's come to the side and factor by grouping. What can I take out of the first one? X. Here I can take a negative 9. So I'm left with x minus 9 and square root of x plus 3. Oop, that's what I need. So x minus 9 over x minus 9 times square root of x plus 3. These cancel out. I'm left with 1 over square root of x plus 3. Now, I plug 9 in. What's the square root of 9? 3 plus 3 is? 3. Okay, so, does that work? Yep, that's my answer, 1/6. All right, number 10. If I take 3 in direct substitution, that's always what I try. 3 minus 3 gives me what? 0. So that's a no-no. Does this situation call for factoring? Is it called factoring? Is there any radicals in it? No. So I'm going to try to find a common denominator here in this numerator. So I'm going to come to the side. What's your common denominator between x and 3? 3x. So if I multiply this by 3x, this is going to be 3 up here. That's going to be x. So I get 3 minus x over 3x. So now I'm going to put that back over here. Or, hold on, I'm just going to leave it right there for a minute. So that is the numerator. That's the solution to the numerator here. I'm dividing it by x minus 3. So I'm going to write that out so I can see what that's saying. That's divided by x minus 3, so that's going to be 3 minus x over 3x times 1 over x minus 3. Now, my question to you is this. Can I cancel these two out? I know they don't look the same, but can I cancel them out? Huh? Why do you flip it? Because you divide by x minus 3. I did flip it right here. X minus 3 became 1 over x minus 3. Remember in Algebra 2, there's a rule. If they are a complete opposites, like this is positive 3, this is negative 3, that's negative x, that's x, do you see that? You can cancel them out, but what you're going to leave there? A negative 1. You remember that? That's the only time, if they complete opposites, you can cancel them out, but if you do, you got to remember to put a negative in the problem. Like that's negative 1. So now I'm left with negative 1 over 3x.
Could you put the negative in the denominator?
Yes, you could. That's fine. Now let's try to plug 3 in now. 3 times 3 is what?
9.
Will that work? That's your answer. Negative 19. Who said, Ivy, what you confused about, huh?
I'm not confused about anything.
Okay. Oh, you're over it? Okay.
So much.
That's nice.
It's
All
not.
right. I know. It's okay. It's okay. I'm not upset. You're fine. You're fine. All right, one more. We're all done. Number 11. Tomorrow we're going to continue practicing this. The limit is x goes to 0. If I take 0 and I plug it in, 0, very good, it's going to be 0. So there's some discontinuity occurring here. What does this situation call for? Rationalizing the numerator. So that's what we're going to do. We're going to do times square root of 4 plus x. So I put minus 2 or plus 2. This is what we're going to take our time here. First, you got a 4. This times this does what with that square root? So what's left there? 4 plus x. This times this is plus 2 square root of 4 plus x. These two cancel out. And then this cancels out. So you're left with pretty x on the top. Distribute, that's going to be x. So I'm left with x over x root 4 plus x plus 2x. So I'm going to plug 0 in and see what happens. If I plug 0 in, 0 times anything is 0. 2 times 0 is 0, so you still get 0. So I got to use another strategy. Do I need to find a common denominator? Do I need to factor? Let's try factor. What can I factor out of these two terms? They both have a what? X. So I'm going to factor that out. Now I can't touch that X under the radical, but the one on the side here, I brought that out. Now can I cancel these X's out? Yep. Now I'm going to plug 0 in. 4 plus 0 is? 4 plus 0 is?
4.
Square root of 4 is? 2 plus 2 is?
4.
So I get an answer of 1/4. That is my limit as X approaches 0. How y'all feeling that today? What you think, Derek?
All right.
I need a hand signal. Okay. We're going to continue this tomorrow, but you do have something I want you to try tonight. Page 13 is looking at a graph. I want you to do all page 13, just look at a graph, omit number 15. We ain't studying the one like 15 yet. And then page 10, 13 through 21 practices these problems. Yeah, omit 15 and 18. Omit 16 on page 10 as well. Sorry, let me get all this. Let me write this. All right, we're going to omit 15 and 18 here. And omit 16 here. I want you to say this. That's what you feel. It's not short. That's identity. Well, I have. Here, is the radicals the ones giving you trouble?
Yeah.
Here, if you look around, what is everybody doing? Parker, if you look around right now, what's everybody working on? Don't finish stuff up early again. What time is it? I might can make that. I got tutoring at 6:30.